Last class, we talked about exponential functions. This time, we're going to talk about their inverses, which are logarithmic functions. Even if you're unfamiliar with what a log is, we're going to talk about how to graph them today. I'm going to give you just a brief lesson on how to convert them back and forth from exponents, but the next class will deal more in depth about what logs are. For this, the purpose of graphing them, this is what we have to keep in mind, is this relationship, that we can convert a log to an exponential function and back. This is read y equals log base b of x. And then, of course, this is x equals b to the y. And we can use that relationship to convert a log to an exponent or an exponent to a log. So, for example, it says write as an exponential function. So the relationship here is y equals log base b of x. And we want to convert that form to x equals b to the y. So that means, this first example, so y becomes our exponent of our base. We'll have x equals 2 to the 4th. And you can see how that's definitely an easier thing to deal with and solve than what we had before. On the same page here, we need to have y is going to be the exponent of our base. So we'll have 9 equals 3 to the x. Now, even though x isn't by ourselves, this is definitely an easier thing for us to solve too, because hopefully we can look at this and say, well, 3 to the 2nd is 9. And now we have something that we can deal with. This goes both ways here though, so let's rewrite this, and I'm going to have to flip it around here. So b to the y equals x, because that's how they wrote these, can be converted to y equals log base b of x. So this first example here, so our y goes by itself. So we have 4 equals log base, and it's going to be b here. That's what they gave us, of 16. Similarly here, our exponent goes by itself, equals log base 5 of x. These are also things we could evaluate, meaning we can actually get a number for. So if we wanted to solve these, yes, you could put them in your calculator, but notice that says without a calculator. So I'm going to rewrite these as exponential functions so we can have them as something that we can solve. And in order to rewrite them as exponential functions, I kind of just set these all equal to x, because we're trying to figure out what this equals. So if I rewrite this as an exponent, 3 to the x equals 81. Well, 3 to what power is 81? Well, that's 4. Same thing here. 36 to what power equals 6? Well, that's a little bit harder. You have to remember that you can use a fractional exponent to make a square root. If I make x to 1/2, that says the square root of 36. Well, the square root of 36 is 6, so that works. Lastly, we have 5 to the x equals 1. That one seems like it doesn't have an answer. However, if you raise anything to the 0 power, it equals 1. Again, we will go more in detail on how this all works back and forth the next lesson, but we needed a quick tutorial on logs. So, like I said, exponential functions and logarithmic functions are inverses of each other. The graph of the logarithmic function y equals log base a of x is a reflection about the line y equals x of the graph. The exponential function y equals a to the x. Use the graph of y equals 10 to the x and y equals log to the x. So they jump right in without telling you that. So we've been talking about log base b. And so we could say log base 5, etc. But if you wanted to say log base 10, they're just going to say log, no base. Also, we learned next on letter E, the number E last time, log base E is going to be natural log. So those are two things that are kind of important for you to remember. Log base 10 is just going to be written log, and log base E is going to be just written natural log. What they did now is graph them for you so that you could see that, yeah, they're inverses of each other. Remember, inverses just switch the x and y values, so they reflect over the line y equals x. We have a nice little chart here describing the exponential function. The domain, we talked about all the domains were negative infinity to infinity. The range was going to be above 0. Well, since we're switching x and y, the domain and the range are flipped. So the domain is going to be, at least for the parent function, is going to be the same as the range. Oh, it is not like that I'm doing this. And vice versa. One thing that we do need to talk about before we turn the page here is the kind of put on the bottom here. To undo a log, you take it to the base of the log. So for example, here this is log. There's nothing written here, so this is base 10 of x equals 3. If I wanted to get rid of the log, you would take both sides to the 10th power. I kind of said that backwards. We want them to be the power of 10. Once that's true, these cancel, and we just have x equals 10 to the third. So for example, over here, let's look at this. We have this. Let's say I wanted to find the inverse. Remember step 1 in finding the inverse is switch the x and y. So I have x equals log y. But the second step in finding the inverse is switching the x and the y. But to get y by, or excuse me, that was the first step. The second step is to get y by itself. I can't get y by itself without getting rid of the log. Well, this is log base 10. So what I'm going to do is I'm going to make both of these the powers of 10. And in doing that, that cancels. So I have 10 to the x equals y. And look at that, they are inverses. We just proved it. Like I told you at the beginning of this, we are mostly going to focus on graphing though. So if you turn the page, which is what I'm doing, we have the same kind of information that we had with the exponential functions. The x-intercept of the graph is 1, because we said the y-intercept was 1 for the exponential. Everything that was x is going to be y, and everything that y is going to be x. Instead of a horizontal asymptote, now we have a vertical asymptote. And of course, this is all just for the parent function. The logarithmic function is decreasing and increasing. This we kind of dealt with this a different way the last class. We're not going to worry about that right now. The graph of f contains the points 1, 0, 0, a1, 1 over a negative 1. The graph is smooth and continues with no graph, with no corners or gaps. So let's talk about that parent function. For the exponential function, I was having you pick the random x values of negative 1, 0, and 1. However, we're talking about an inverse, so we're going to have that backwards. Now that's going to be our y. When we plugged those in, when we plugged negative 1 in for our exponential functions, we got 1 over a, 1, and a. We just switched our x and y. We will get to graphing on the next page, but I want to make sure we can find our domain. So to find our domain, algebraically, if we have this function, f of x equals log base a of bx plus h, that looks familiar, right, the h value. In order to find where our domain is, we are going to set the parentheses greater than 0, kind of like we did with the trig functions. So for this one, here's our parentheses. So we're going to do x plus 3 is greater than 0. Subtract 3 from both sides. And this is our domain. Granted, we've been writing that as -3 to infinity, and that'll be more evident as we graph, but let's try another one. So we're going to set the parentheses equal to 0. That's kind of a bigger pain in the butt for this one, isn't it? So we're going to have 1 plus x over 1 minus x is greater than 0. Well, to get rid of this denominator, I'm going to multiply both sides by 1 minus x. So those cancel. 0 times 1 minus x is going to be 0 again. So I'm going to have 1 plus x is greater than 0. Subtract 1 on both sides. So my domain is x is greater than -1. The other issue I have here, though, is, you can't see it because I wrote over it a little bit, I have a denominator here. And if I have a denominator who ends up being 0, the world explodes. You can't do that. So we're going to have to figure out what will make that denominator not equal 0. So we want x, 1 minus x to not be 0. So add 1 or subtract 1 from both sides. So I have -x can't be -1. So x can't be 1. So with those two pieces of information, my domain, I know x is going to be greater than -1. So I'm going to start at -1, and I'm going to end at infinity. It's going to be greater. But I know I have to make it stop here at 1. So I'm going to go to 1, union, 1 to infinity. And that's the hardest. That's okay. I don't believe you're going to see one that looks like this, but just in case, we have the absolute value of x as our log here. So we have the absolute value of x has to be greater than 0. And it's been a while since we've dealt with absolute value. If we have absolute value, we have to do x is greater than 0, and we have to do negative x is greater than 0. For this side, we're done. This side, we have to divide by -1. And whenever you divide by a negative, you have to switch the sign. So that means our domain is going to be x has got to be greater than 0, and x is going to be less than 0. So we're going to go from -infinity to 0, stop at 0, and start back up again on the other side of 0. But like I said, that's as hard as that possibly can get. So let's start actually graphing these things. Find the domain of the logarithmic function. Graph the function. From the graph, determine the range and the vertical asymptote. Find the inverse. Find the domain and range of the inverse, and graph the inverse. So there are a lot of things going on here. So let's just start at the beginning. Find the domain and the range, part A. Oh, not even the range, just the domain. Okay, I said set the parentheses equal to 0, greater than 0. So x is greater than 2. So our domain is going to be 2 to infinity. And we're done with part A. Part B. Graph. Okay, so we need to start with our parent function. So to start with our parent function, we know from the other page that it's going to be 1 over A, 1, A, and -1, 0, 1, because our x and y values are switched from last class. We just have to figure out what our a is. So this is a log, but it doesn't tell us what our base is. Remember, this is an abbreviation of log base e. So that means our parent function is going to be x, y, 1 over e, 1, e, -1, 0, and 1. And now we have to help save random victims. Help save random victims. So looking at our function, that -2 means we're going to go right 2. We do not have a stretch or a shrink. We are going to reflect over the x-axis, which means we are going to change the sign of y. And we do not have a vertical shift. So we're going to go right 2. That means we are going to have 1 over e plus 2, 3, and e plus 2. And our y values are going to stay the same. For our reflection, we're going to change the sign of y, which means our x is going to stay the same. And change the sign of y. Okay, at this point we put this little mess in our calculator, and this is going to be 2.37, and this is going to be 4.7. And we are going to graph. So this will be x is 2.37-ish and 1. I didn't draw. 2.37 and 1. We have 3 and 0. And we have we have 4.7, so 4.7 and -1. And we connect the dots. And we even found out up there that x has to be greater than 2. So we have a horizontal asymptote here, and I think I'm getting ahead of myself. Part C. I am getting ahead of myself. So part C. From the graph, determine the range and the vertical asymptote of f. Well, the range goes up forever, down forever, so it's going to be -infinity to infinity. And our horizontal asymptote is x equals 2. Okay. Now it says find the inverse of f, and we're just going to find it. So part D, we're just going to find the inverse of f. So remember, find the inverse. Step 1, switch the x and the y. So we have, and I'm going to write out the log as log base e, and switching x and y, because that's how we find the inverse. But now we have to get the y by itself. So there's a lot of things that are in our way. First thing I'm going to do is I'm going to multiply both sides by -1. So I'll have log base e, y minus 2 equals -x. Now to get rid of the log base e, I'm going to make both sides the exponents of e. So this will cancel, and I'll have y minus 2 equals e to the -x. And we're almost done. Y equals e to the -x plus 2. And that's our inverse. We did it. says find the domain and the range of the inverse of f. This is actually a lot easier question than you think, because all you have to do is find the domain, take the domain and range for the function and switch them. So for the original function, the domain was, we didn't even say the domain, did we? Oh, we did, was x is greater than 2. So that means the range is going to be x is greater than 2. And the range for the function, for the original function, the range for the original function was negative infinity to infinity. So that means the domain of the inverse is going to be negative infinity to infinity. Inverses just switch the x and the y. And the last part, I guess I'm going to go over here. The last part says graph. So you would think, okay, we would need to make our parent function and then do the help save random victims and all that kind of stuff. But since I've been telling you that all we have to do is switch x and y, we can do that here too. So take the final chart that we had for part B and switch the x and the y. Makes our lives much, much easier. So I drew the first one in green. Let's draw this one in blue. Because it does actually graph it. So here we are. We had a we had a horizontal asymptote at x equals 2. Well, now we're going to we had a vertical asymptote at x equals 2. Now we're going to have a horizontal asymptote at y equals 2. I think this will be easier to see it right. We're going to do it right. I lied. Okay, so we have a point at 1 and 2.37. We have a point at 0 and 3. And we have a point at negative 1 and 4.72. And it's going to go. And remember, inverses, when they switch x and y, they do reflect over the line y equals x. You can see how if we folded this paper in a diagonal, it would actually graph each other. Okay, I'm going to do one more with you. So flip the page, and I believe we have the same set of instructions. We do. So find the domain of the logarithmic function. F of x equals 3 log x minus 1. I don't have a base here, so that means my invisible base is going to be 10. So the first thing they want me to do is find the domain. So set the parentheses equal to 0, or greater than 0. So x minus 1, and I'm taking both of them, is greater than 0, so x is greater than 1. And in interval notation, that's just going to be 1. Look at us go. Okay, so we need the graph, which means first we need our parent function. So we have x and y. And since we're switching, this will be negative 1, 0, and 1. This will be 1 over a. A is our base. And since it was invisible, we know it's 10, so 1 over 10, 1, and 10. So now we need to help say random victims. So we have h. We are going right 1. Right there. We're going to go right 1. And s. We do have a vertical stretch. So we are going to multiply y by because that 3 that's out front. We do not have a reflection and we do not have a vertical shift. So let's get our t-charts. So if we're going right 1, that means our x's are going to have 1 added to them. So we have 1 and 1/10, 2 and 11. Our y values are going to stay the same. For our stretch, we're going to multiply y by 3. So we're going to keep our x values the same. So we have 1 and 1/10, 2 and 11. And we are going to have -3, 0, and 3. And now it's time to graph. So let's graph this. X is 1 and 1/10 and -3. We have 2 and 0. And we have 11 over here and 3. But I didn't connect the dots, that's the problem. Okay, so we already know that x is going to be greater than 1. So the next part of this, because that's what they're going to ask for, part C, is find the range. Well, the range is always going to be -infinity to infinity. And the vertical asymptote is going to be x equals 1. Part B. Switch the x and the y to find the inverse. So we will have x equals 3 log of y minus 1. We have to get the log by itself before we can get rid of it. So let's divide both sides by 3. So x divided by 3 equals log of y minus 1. Remember, to get rid of a log, we're going to make it the power of whatever the base is. So our invisible 10 is now going to be the base of an exponent. These will cancel. And we will have 10 to the x over 3 equals y minus 1. So y equals 10 to the x over 3 plus 1. Remember E, you just take the domain and the range from above and switch them. So our range was -infinity to infinity, so now that's our domain. And our domain was 1 to infinity, so now that's our range. And finally, to graph it, when I even have space, we're just going to switch our x and our y. So -3, 0, and 3, 11/10 or 1 and 1/10, 2 and 11. So let's graph it. So -3 and 2, 3, and 1 and 1/10. We have 0 and 2, and we have 3 and 11. I have to move my graph. 3 and 11. Connect the dots. We have a horizontal asymptote here at 1. And we are done. I'd like you to take the next amount of time and do the 2 that say try on your own. Tear off that page and turn it in, please. Thank you very much.